Water is used in buildings for drinking, washing, and cooking. HVAC systems circulate water for heating, cooling, and maintaining proper humidity levels. Fire protection systems store water for extinguishing fires. This week we'll talk about how water is supplied to a building. Here are some water facts. The numbers that you see here are for daily use. So the average person uses 14 gallons of water for laundry each day, but 32 gallons a day to flush the toilet. 70% of the surface of the earth is water, but 99% of it is inaccessible to us. So our drinking water and our usable water essentially is 1% of the earth's water supply. The demand for water currently in Phoenix ranges from about 442 million gallons per day in the summer to about 136 million gallons per day during winter months. About 95% of the water used in Phoenix comes from surface sources, including the Salt, Verde, and Colorado rivers, and then the remaining 5% comes from wells. The most important thing to note about water is that the total amount of water on Earth is finite. It does not change unless something was to come in from another planet or outer space. The hydrologic cycle circulates this water. The water moves from the Earth to the air to the Earth again. It changes from solid to liquid to gas and over again. Transpiration is the evaporation of water from plants. Precipitation is the most accessible source of water, but groundwater makes up the majority of our water supply. Rainwater is the purest form of water. Much of its quality is good enough to provide about 95% of indoor residential water requirements. Early societies, of course, depended more on rainwater than we do today. With the advent of a centralized water treatment plant, rainwater collection and its use has become less common. Now the lawns in many subdivisions slope toward the street that then directs water into storm drains that dumps it far from where it started. Residents who wish to make use of rainwater must purchase the systems themselves while still paying city water taxes. While acid rain or rain that has been affected by air pollution can be an issue, so can bird droppings or dust or other things that can collect on the roof. Steep roof slopes tend to stay cleaner for rainwater collection. There are many systems available for collecting and using rainwater, but basically what you need are three things: a collection area, a transportation system, and a storage facility. World water usage has dramatically increased over time. We have gone from using 10% of the supply in 1950 to 50% in 1980. The increasing population and consumption puts pressure on the clean water supply, thus threatening world health and political stability. In addition to per-person use of water, agriculture and industry use vast amounts. You can see here we've got large fountains at the Bellagio and big sprinkler systems to grow flowers and plants. Designers must pay attention to and disregard the extravagant landscape designs, water features, golf courses, and swimming pools that can have a negative effect towards the water supply, especially here in the desert. Potable water is water that's safe to drink and cook with. It's free from any harmful bacteria, and it's carried from the public supply directly to homes and businesses in large underground water mains or pipes. Hard water is when calcium salts in the water make it hard and allow it to cause scaling on pipes and turns soap into scum. Water softeners also often will be used to remove calcium and magnesium salts by ion exchange. Now, there are several aspects of the city water supply system that you will want to understand. First, there's the city water main, and that's essentially a large pipe that carries potable water from the municipal supply, where they've treated it and cleaned it, to the service connection at a building. The service pipe is installed by the utility company and runs from the water main to the building. The water meter measures the amount of water that's then taken in by the building and can also be used to measure sewage disposal from the building. And then there are two control valves. One is located at the building to allow the resident to shut off the water supply if necessary. And then the other one is located in front of the property, and that's what the city water utility will use to shut off the water supply if you don't pay your bill. City water is kept under pressure so that it can be delivered to buildings, offsetting friction and gravity. Once the water is inside the building, the pressure is changed by the size of the pipes that it travels through. Bigger pipes put less pressure on the water, and smaller pipes increase the pressure. If the pressure is too high, pressure reducers or regulators are installed on the fixtures. This water pressure can reach up to 6 stories. Buildings with more than 6 stories, water is either pumped down through a roof storage tank or pumped up to the roof storage tank, and then gravity is used to distribute the water through the building, or it's possible additional pumps can be used as well. Now, another way to get water is to dig a well in the ground. Wells should be dug very deep to ensure water quality. The deeper the well, the further the water had to travel underground, which helps filter it. Wells are sunk below the water table so not to be affected by seasonal changes and contaminated by surface water that could be affected by sewage, garbage dumps, animals, barns, fertilizers, that sort of thing. Pumps will bring water from the base of the well to temperature-controlled storage tanks, where the water is then stored under pressure and can be filtered and chlorinated. Well water is more reliable than rainwater usage, of course. For indoor plumbing to be safe, it's necessary to separate the water and waste into 2 separate systems. So we have the water supply system, which delivers the clean water, and then the sanitary or the drain, waste, and vent system, which removes waste from the building to the sewer below. Next week, we'll talk more about the drain, waste, and vent system. Now, in wood frame buildings, the plumbing is usually located in the walls, as you can see in this photo here. It can also be put inside the floor joists as well. In masonry buildings, the wall must be furred out, or basically they put wood strips on the stone or the concrete to create a space to allow room for the pipes. If a building's more than 3 stories, then a 2x6 needs to be used for the extra space. Many commercial buildings will put the pipes in the ceiling. Larger buildings build pipe chases, which are vertical or horizontal open spaces that house the plumbing and contain access doors for easy maintenance. These are placed in the building core, which we learned about last week. And there are two main types of distribution systems. First, we have the upfeed distribution. This is where the city or the building relies solely on the existing water pressure for distribution. And then the pumped upfeed distribution, where the water is then pumped through mechanical means into either a storage tank at the roof or somewhere else in the building. Plumbing supply pipes can be made of copper, brass, steel, and plastic. Steel pipes are strong and inexpensive but can corrode and spring leaks. They only last about 20 to 50 years. The brass are the most expensive pipes, but they have very good corrosion resistance, so they'll last a long time. Copper also has very good corrosion resistance, but they're twice as expensive as steel. But they're also easier to assemble and they last twice as long. They're joined with a solder rather than a threaded connection, which eases installation, so the plumber can basically melt them together. And they also allow for pipes to be thinner because no threads have to be built into the thickness. They create less interior friction as well. Plastic pipes are very low cost. They're corrosion resistant. They can be used indoor or outdoors, depending on the type of plastic that's used. But they do require a little bit more maintenance and must have maintenance access. I remember in a house I lived in North Scottsdale that was built in the 80s, the city actually had to come in and replace all the plastic piping that was in all of everyone's front yards because it was leaking and failing. Now, cold water pipes should be insulated to keep the water cold, but it's not a very common feature. Hot water pipes definitely need to be insulated, especially if they're exposed. If you're designing a commercial restroom and there's exposed pipes under the sinks, the hot water pipes must be insulated. Now, this is a roughing in document. If you browse Kohler's website and you find a fixture that you like, they allow you to print these sheets. These are the sheets that you give the contractor or the plumber so that they know how large your fixtures are and how to plan for them. Roughing in is the process of getting all the pipes installed and then capped and pressure tested before the fixtures are installed. This happens fairly early on in the construction process. All right, so we'll talk a little bit about hot water. DHW, domestic hot water, is water that is basically heated by some sort of water heater. There are various types of water heaters. What you see on the left is basically the standard, most common storage tank water heater. Residential and small commercial buildings usually use these, and they're typically centrally located so that they don't have very long runs to each of the fixtures. They typically have 20 to 80 gallon capacities and can be heated by gas, propane, fuel, oil, or electricity. Electricity is going to be the most expensive way to heat the water. Here in my house, we have a gas water heater. Now the water enters at the bottom of the tank, and then basically there's a pilot light, and the water is continually heated. Now the one that you see in the center, this is a solar water heater. These are all over the rooftops in Greece. The round part you see is a storage tank, and then of course that solar panel in front. So when we're in Greece in the summertime, we pretty much can get our water, all of our hot water, through this water heater. In the winter, when there's less sun, we need to use an electric heater as well. The solar water heater will raise the temperature of the water before it hits the other water heater, so then less energy is used, and it can really cut the average water heating bill by 40 to 60% a year. Now, the one that you see on the far right is what's called a heat pump water heater, and it takes excess heat from air in hot places like in a kitchen or in like a mechanical room, and then it dehumidifies the air and uses it to basically heat a storage tank water heater. A really great option now are these tankless water heaters, and they use a really large amount of heat but for a short period of time to heat a limited amount of water. Essentially, they're usually installed at the fixture, so when you turn on the shower, intense heat will heat that water, and then it'll stop heating it when you're finished. So you save a lot of energy costs because you're not heating water that you're not using like you do in a storage tank water heater. So some ways that you can save energy and reduce the cost of heating water is locating your water heater in a relatively warm area so it's not losing heat to the cold air surrounding it. Low flow shower heads and faucets can save both heat and water. A hot water recirculation system is basically a series of pipes with a motor-driven pump that will recirculate water between a water heater and a hot water faucet. And you can use, of course, computer controls to save energy so that it only heats the water at the peak times or the times that you really need it. Now, hot water pipes are arranged in distribution trees, and the water is circulated using the thermosiphon principle, meaning that water will expand and become lighter as it's heated. So warm water rises to be used, and then when it's cooled, it returns to the bottom of the tank. If buildings are too low or too large for thermosiphon, then they must use some sort of mechanical means to circulate the hot water. So in many parts of the world, especially here in the Southwest in the desert, water resources have been a long-standing concern. But it's interesting because water efficiency standards tend to be limited when compared to energy efficiency standards. Building design professionals and clients are beginning to respond to this, and we see a lot more use of things like low flow toilets, self-closing public toilets and faucets, low flow shower heads, and those sorts of things. This week we learned how water is supplied and distributed, and next week we'll get into more of those plumbing design principles.